Hello there, welcome back. This is me, and this is lesson 20 in our tutorial. I want to point out a couple of things from last time. Last time I actually showed you a little bit of C code, and I compiled it in fact. I wanted to mention something about that little program, which is still there. I removed the include line and just took out the bits that we want, and that is the prototypes, or the two functions that we used that we didn't write ourselves. One being this get with echo, get a character with echo, and this one being a put character with echo, just put, that is an echo. But the thing I wanted to point out specifically is this int here. A lot of people wonder, and I wondered too, when I first ran into this function and similar ones, why is it that this function says gets a character, and I know what a character is, that's only 1 byte, 8 bits, but it returns an int, which in the 16-bit world is 2 bytes, or 4 bytes in the current world. And that always confused me. Why does it return, why does it say it's getting a character and it doesn't return a character? Now that should be something that you already know the answer to. And the reason is basically this. Remember, we talked about how values are returned from functions. Values are returned from functions always in the AX register. Return values are always in the AX register, or in 32-bit case, EAX register. And ints, integer values, same size as register. So that is, it's impossible for a function to return a value that's any smaller in size than an int, because the return values are always in a register. So that explains that bit away. It is possible. You could declare a function that returns a car, say. But that's not actually what's happening. What would happen here would be a value would be put in AX, and maybe the value would be uh, 23 or something, and if there was anything else left over, that would be somehow erased. So maybe this would be, and so the return value would be like something like that, this bit, so that would get rid of the 2 here. But in the end, what is handed back to your function is going to be a full 16-bit value, or 32 bits nowadays. So this is just a little bit of honesty here. They're telling you that the size of the return value, even though it's a character, is stored in an int. A lot of people might think, well, okay, well, that's great, but maybe it uses those extra bits for some reason, like end of file would be a good use for that, for the extra bits. But if you go and look at the help, And I've actually gone and looked it up. It's in here somewhere. That's the bottom. This is the help on Getch. Gets a character from the console. This is also going to help us later. With echo. Return value returns the character read. There's no error return. So really and truly does not use the extra space available in that integer value. Same for Getch. Those are two functions that are specifically to do with the console. And that's another thing I wanted to mention. Why this function, our main thing, where is it? Didn't behave like our COM program. And now I'm going to put it back again. Get rid of that. You see, these two functions have to do with something called a console. And the console is essentially either the keyboard or the screen. So redirecting is not going to change the fact that the keyboard is the keyboard or the screen is the screen. And that's why this thing kept fetching its characters from the console and not from the file that we thought we were redirecting the console to. What we really want, if we want to make this thing the same as our little program, is we need to change this from using the console input or output to using what they call the standard input and output. And that's what we're using. We're using standard I/O, whereas this thing is using console I/O. We'll get to that shortly. This is what we have. Second thing I wanted to point out was this build process. Now, I have a compiler on here called CL. It's a Microsoft compiler that I actually paid for. And the command line here, CL, at simplest form, actually does two things at once. And maybe it's called CL because of that. It compiles and then links. Now, you don't probably know what those two words mean, but I'm going to tell you. First part, compile. The compile part is the part that takes our little text file, main.c, and turns it into machine code, basically the stuff we've been working with directly, the debug program. And unfortunately, since this, after compiling, is a 32-bit program, we can't use debug to step through it. However, if I run CL, you'll notice, forgetting about all this mess, two files appear that weren't there before. First file is called an object file. This is the part that contains the machine code for corresponding with this. The second file is something you can actually run. Now you'll notice the difference in size here. This is 45,000 bytes big, which is a great big, huge thing. And this is tiny because we don't have much in our program. Now, main here is not really of very much interest to us. This part is. This should show us the disassembly of this, if we could get at it, and we can. I have another program on here called DUMPBIN, and it will allow us to look inside that OBJ file. And I'm going to use the disasm switch, disassemble main OBJ, and it scrolled off the screen, so I'll put it into a text file. Call it asm, I guess. Okay. Now, even though this is a 32-bit program, we can at least look at the disassembly of it. So this was compiled with debug by default, so we got the symbols and everything in here. And we can see the usual enter and leave code. This little bit here is corresponds with, let's get our C file. Okay. Now this for initial assignment here corresponds with this. Remember, BP is the way we reference things on the stack. Minus if it's a local variable, and plus if it's passed in variable. Now, this push CX might be its quick way to allocate one int worth of stack space, because that would have the effect of adding, subtracting 4 from the stack pointer. And then in order to get the value back, we would have to subtract 4. Okay, no problem. So we do that. Here's the call to the function, get a character. Now, first thing it's doing here is it's putting whatever was in, it calls the function, takes no arguments. You look here, takes no arguments, so it just calls it straight off. The return value is in AX. Remember, it can't be any smaller. Store that in our ch variable, this guy. Okay. And now there's a comparison with the D, which is a carriage return. Now they see they've changed one. They've changed this slightly from what we typed in. I said if it's equal to D, but it's checking if not equal. So they're fooling us a little bit, or optimizing for us. If it's not equal to a D, it's going to go to 23. So now we'll scroll down to 23 here. Okay, now what does 23 do? Another comparison. So you see that there's nothing really, there's no magic going on here. Another comparison, if not equal to the end of file character, jump to 2B, use 2B, well, there's another jump which says go to B, and go up to the top, and here we are starting over again. Okay, so that's great. So we can at least look and see the difference between C and what we're doing. So those are two interesting things. Now, not so interesting for you because you can't do either of these things. So that's why I made this up. Okay, now, first those interrupt values I've been using, you can find all those values here. Give you some time. You can hit pause if you want. You take these in. These URLs in. That big long list of instructions, Intel instructions I showed you before, can be found at this location. The DUMPBIN program that I just made use of can be found here. Our SourceForge friends have a copy. And I don't know, this might not be the version you want, but there is a free version of the compiler that I'm using, which is Visual Studio 2005. Express is the free version of that, which has almost all the same features, just no optimizing, which we don't need anyway. I found that here. You can't read it all, can you? So I'll just do that. So if that helps. That's all one line. So get a copy of that, and once you've installed this, you're going to have to play around with your path and make sure that you get CL in your path if you want to do what I did just there. Otherwise, it has a development environment where it's quite easy to write code and press F1 for help and so on and so forth. Okay, so that's that. There was something else I wanted to say. Okay. Right. Now, so let me get rid of that. Don't want that. Don't want that anymore. And so what I'd like to do now, given that we can do that, is look at the C equivalent of really of what we have. And I've written that too. I think I put it hidden. Yeah, there it is. Alright. Okay, now, so the first thing you'll notice in this file is that instead of con.io, now we're using standard IO. I moved the CH from where it was here over to here to try and keep things simpler to read in the disassembly when we look at it. That is, there won't be any fiddling with the BP or anything here. And what used to be, let's load both of them up. So this line here has now become this line here. Get C. Now get C is a function that takes an argument with it. And that argument, this particular value I've passed in, is something called, is a special value, which is in fact a data structure called a capital file. There is a data structure called file, Now I don't know what all the members are. It's got some members in it. And if we wanted, we could find out exactly what that is. I could go and check quickly, but it doesn't matter. It doesn't matter. The point is that there's a bunch of data inside this structure that has to do with files. Okay? And this thing is a pointer to this type of data structure. So standard in would be, if we didn't have our header file, would be declared this way. It's a global variable, an extern, and it's a pointer to a structure of type file, and it's called standard in. Similarly, there's another file star called standard out somewhere in the world, and I'm using that here. Okay? Now all files, when we open them in a specific way, anyway, come in this form. Okay? These ones are provided for free. The system creates them for free for us, and we don't have to open or close them or anything. And we can read from a file using this getC. And we can write to a file using this putC. So those two lines together do this part. Get a character, and this is the echo part that we didn't even want in the first place. But there it is. The rest of this program is essentially the same. Except instead of 1A for the end of file character, here they've invented a new number, turns out to be -1, that if we read a character and we get a -1, that tells us we hit the end of the file. Okay? And that's essentially all there is to it. The rest of the program is exactly the same. And I can compile this. I gotta get rid of this. It's already there. We don't want this. Commentary. File this. And just for your curiosity, is it Tisazin? Like that. We'll notice that there are a bunch of changes here. This here, if you actually follow it along, is the part that retrieves the standard in file object, turns out. So that's hidden from us. And then it returns a value in AX like everything else in the world and gets pushed on stack for getC to use. And the rest is all the same as before, essentially. You can look closely at this but you won't be able to see that particular bit unless, no, I can't bring it up easily this way. Something else in here? No. But that's not important. The important thing is that this new main standard has some slight differences from our program. One of the differences is when I press enter, the entire line that I just typed gets echoed out onto the screen. So that's different. Control Z will still get us out, but I can't just put it anywhere I turn. So I tried this. See, it stopped reading that line, but it didn't really exit the program. I'm not really sure why that behaves that way, but certainly on its own it will get us out. So it has some of the features we want. And you'll notice that I can type any of these text files, even if they don't have an end of file marker. Just standard. Oops. What we call main standard. And it properly quits, prints everything out and properly quits, even though there's no 1A at the end. So 1A has kind of disappeared using the method of reading and writing to standard input and standard output. That way. So that's what we want to achieve by the end of the next lesson. So I'll call this addendum to the last lesson, and the next one, the real lesson 20, will be at this point, maybe further along. Okay, till then, bye.